What's up, guys? Now let's discuss binary data formats. We'll talk about how they compare to textual-based formats, and we'll also talk about the commonly used binary formats in today's world. So let's get into it. So let's just introduce this. Text-based data representation is preferred when interacting with different clients, especially when client implementations are outside of an organization's control. It's easier to debug when the data is human readable. When the applications are internal, and say you have an iOS and Android app where organizations or one organization controls both ends of the communication, so it owns the client and the server, there's more freedom and flexibility in choosing a data format. Binary formats are more compact, faster to parse, and lighter on the database. So binary formats share the following benefits. They're all machine friendly, so they're processed with little or no pre-processing. They're schema dependent, so data related information is defined in the schema document. They're all very portable, so binary formats can be easily deserialized into different languages as long as they have the same encoding and decoding schema. They all have precision support, so they can store really large numbers with really good precision. They're all standardized. They use well-defined schema that's well documented and can be standardized across different implementations. So the binary formats that exist are MessagePack, Fast InfoSet, BSON, WBXML, Protobuf, Thrift, Avro, etc. So this following picture is actually in MessagePack, and here we have our message, our body, and we have a field here called disable links. Disable links with a value of true, right? So this just looks like typical JSON. And MessagePack and other binary variants of JSON and XML follow a schemaless encoding style that increases the size of encoded data, right? And disable links takes 12 bytes in MessagePack, right, to encode the field name, and the value is only 1 byte just to represent true. So here we have our disable links, 12 bytes of data for the field, and 1 byte for our Boolean representation. So let's talk about Thrift and Protobuf. So Thrift and Protobuf are the most common used binary data formats. Google developed protocol buffers, and Facebook developed Apache Thrift. You can break down these schema definitions as follows. So first you have tags. So each field is identified by the numbers equivalent to the names. So here we have a 1. So 1 identifies the field's node ID for Thrift, right? Here you have a 1. Node ID for Thrift and node ID for Protobuf, right? And they're encoded in data rather than field names because they're much more compact data representation, right? And labels. So labels, they're the markers required, optional, repeated. So here we have our labels. And this is repeated is only for Protobuf, right? And it implies a check to determine whether to raise an error when encoding or decoding. So only added to the schema but are not encoded in the transmitted data. You also have types. So each field can identify its data type, string, I64, int64, etc. by specifying a type marker. So Protobuf uses the repeated label to represent an array. So Thrift doesn't have repeated, but if you want to represent a list or an array, you can say your data type and then you can put repeated there to represent a list of string. And You also have names. So the markers node ID, etc. They represent the name of the data entity. These are not identifiers for the fields, right? But it allows the name to be changed without affecting the implementation. So what's important is actually the tag. So now let's discuss Apache Avro. Apache Avro is an open source binary encoding format developed by Hadoop. It supports two schema styles, Avro IDL and JSON based definitions. It doesn't add tags like in Thrift and Protobuf. It uses value only encoding style. So that is interesting. So schema version is defined in the data reader to identify the fields when decoded. If any conflicts due to different versions of the writer's and reader's schema, Avro library resolves these conflicts through a side-by-side comparison. So let's go through this picture so it makes a little bit more sense. So here we have a post URL, and as you can see, our reader schema doesn't exactly match our writer schema, but it does get mapped to the correct row in our reader schema. So then we have our post ID. Our post ID is an integer, but it becomes a long, right? As you can see, the field is modified by this color. And then we have privacy. This field doesn't exist in our reader schema, so it's removed based on this color, so it's removed. And then we have a list of strings, or an array of strings, post tags, and that exists in our reader schema, so that gets mapped correctly, right? So Avro kind of does this mapping and removes any fields, or if there's a value or a field that it feels like it's missing, it'll just add a default value for you. So field name is used as the field's identifier, right? And records can be in any order as long as the field name remains the same. If the reader code finds a field that is not in the reader schema, it just ignores the field, like in this case. And if the record doesn't contain the fields expected by the reader schema, the reader code populates it with the default values specified by the reader schema. So if it doesn't find the value for likes, it'll just be populated with the default value defined in the reader schema. So how does the reader know the version of the schema is used to encode the data? So Avro proposes several solutions to specify the writer's schema in different scenarios. Some of them are as follows. To store large files, it attaches the writer's schema once at the beginning of the file. To store individual records, it maintains different writer's versions in the database and specifies the version number in each individual record. Sorry, I'm a little bit sick, so. To send data on the internet, it shares the writer schema when setting up a stateful connection, right? So Apache Avro is very flexible with dynamically generated schemas. It handles schema transitions efficiently when decoding. Admins don't need to worry about updating fields like names, tags, types, and so on. Thrift and Protobuf generate dynamic code and perform compile time checks for different statically typed languages. Avro supports dynamic code generation over statically typed languages. So let's discuss the advantages and limitations of binary formats. Binary formats are much more compact and faster in terms of processing than text-based formats. They're flexible with clearly defined version compatibility, dynamically generated code support, and the only limitation with it is that it requires pre-processing to make them human readable. So, JSON you can just read it, but this requires an extra step. So let's do a feature comparison between the different types of binary formats we discussed. So here we have Thrift, Protobuf, Avro. And so for schema document, Thrift has a static schema document, so does Protobuf, and Avro has static and dynamic schema document, right? None of them are human readable. They're all very fast. Avro being the fastest since it has the most compact size. They're all very standardized, machine friendly, interoperable, and very flexible. So let me give you some recommendations if you are going to choose a binary format or any type of data representation for your API. So choosing a data exchange format for an API is always debatable. JSON is usually the ideal choice with dealing with small groups of systems where human readability is important. XML is the ideal format when dealing with various systems with complex data structures that require markup and human readability. Avro is the ideal choice when dealing with large file sizes, frequent interactions of data encoding, using different schema versions. So there's significant encoding sizes. So protobuf or thrift will serve the purpose when network latency, inter-process communication, and processing speed are paramount. So the choice is not limited to the data formats above. There's also YAML, form data, SQL, etc. There are also custom formats. So let's do a quick quiz. So why is binary data small in size and high performing compared to textual ones? So binary representation uses compression algorithms like LZ77, RLE, etc. to reduce file sizes. So it reduces markup. You can define schemas for serializing, deserializing data. They're transmitted once and then saved in the database to reduce the size of the payload. There's no need to convert from another format for processing. So you don't need to convert anything. It's just binary. The computer likes it. And hopefully you learned something. Thanks for watching, and check me out in the next one.